Good morning, students. Welcome to Bindu Dadwal Chemistry Lessons. Our topic for today is organic compounds containing nitrogen, the 12th unit of your book. So, the important classes of organic compounds containing nitrogen as part of functional group are amines. Amines can be categorized into three categories: primary amines, secondary amines, and tertiary amines. In primary amines, there is only one alkyl group. In secondary amines, there are two alkyl groups with NH functional group. In tertiary amines, there are three alkyl groups and a lone pair of electrons. Another class of compounds containing nitrogen is cyanides. They can also be called nitriles. We have isocyanides where alkyl group is attached to N of CN group. We have nitro compounds. We have nitrides where the NO2 is attached through oxygen to the alkyl group. And then we have benzene diazonium chloride. These are called diazonium salts. So first part is amines. They are regarded as derivatives of ammonia. If we replace one hydrogen of NH3 with alkyl group, we get primary amine. If we replace another hydrogen of this primary amine with another alkyl group, we get secondary amine. And if the third hydrogen is also replaced with a alkyl group, we get a tertiary amine. Importance of amines. Amines are important class of organic compounds. Amines also form components in plants and animals as proteins, vitamins, alkaloids, hormones, etc. We also have some synthetic compounds containing amines. These are polymers, drugs, dyestuffs, etc. Quinine is a very important drug which is used for the treatment of malaria. It's an anti-malarial drug. Then adrenaline and ephedrine, these increase in blood pressure. Novocaine is an anesthetic used in dentistry. Codeine is used as analgesic. Benadryl is an antihistamine drug used to treat coughs, allergic coughs. Quaternary ammonium salts are also used as surfactants. So amines can be classified into primary amines, RNH2 or ARNH2, aryl group, or secondary amines, R2NH, or tertiary amines. So nitrogen compounds can be categorized as ammonia, primary amines, secondary amines, and tertiary amines, and ammonium salts. Amines may further be classified into two categories: aliphatic amines, amines in which nitrogen atom is directly bonded to one or more alkyl groups is called aliphatic amine. For example, methylamine, dimethylamine, or trimethylamine. Aromatic amines, these are again of two types: aryl amines and aryl alkyl amines, in which the nitrogen atom is directly bonded to one or more same or different aromatic rings or aryl groups are called aromatic amines, and the amines in which nitrogen atom is bonded to side chain of the aromatic ring are called aryl alkyl amines. So aryl amines can be aniline, C6H5NH2, diphenylamine, and triphenylamine. Arylalkylamine can be benzylamine, dibenzylamine, and so on. Then we can also categorize them into simple and mixed amines. If all alkyl or aryl groups attached are same, then it is called simple amine, and if they are different, it is called a mixed amine. Dimethylamine has same methyl groups, so it is a simple amine. So dimethylamine, triethylamine, diphenylamines are simple amines, and methyl, ethyl, methyl, propylamine, and methyl aniline are mixed amines. Nomenclature of amines. So in case of aliphatic amines, we have common system as well as IUPAC system of nomenclature. Common system, we can call them as alkylamines. For example, CH3NH2 will be called methylamine, ethylamine. This is ethylamine, this is propylamine, this is dimethylamine, diethylamine, methylethylamine, triethylamine, N, diethyl butylamine, and N-ethyl cyclohexylamine. According to second system, common system, they can also be called as aminoalkanes. So this is aminoethane, this is 2-aminopropane, 3-methyl-2-aminobutane, this is 2-aminopropanol, this is 3-methyl-2-aminobutane. This is 2-aminobutanoic acid. In IUPAC system of nomenclature, we call them as alkanamines. So this is methanamine, ethanamine, cyclohexanamine. This will be 4,4-dimethyl cyclohexanamine. This is ethane 1,2-diamine. This is phenyl methanamine, and this compound will be called 2-methyl-3-phenyl propane 2-amine. In aromatic amines, again in common system, we call them as arylamines, and this is called aniline. This is also accepted in the IUPAC system of nomenclature. So in IUPAC systems, these are called benzenamines, but aniline is also accepted. So this is N-methyl-benzenamine or N-methyl-aniline. So this is 4-bromo-benzenamine or para-bromo-aniline. This is 4-methoxybenzenamine or 4-methoxyaniline. In case of polyfunctional group, amino will be considered as substituent in presence of a principal functional group. So this compound is 3-aminobutanoic acid, and this is 2-nitro-N-methyl-2-nitropropane-amine. In case of unsaturated amines, the amino group is given the preference. So numbering starts from this end. So the name will be prop 2-in-1-amine. It is also called allyl amine. Isomerism in amines can be chain isomerism, metamerism, and position isomerism or functional isomerism. Chain isomerism, when aliphatic amines have the same molecular formula but difference occurs on the chain of the alkyl group. For example, butane 1-amine can have chain isomer 2-methylpropane 1-amine and 2-methylpropane 2-amine. Metamerism, this is due to different natures of alkyl group attached to the same functional group. So functional group is NH. In this isomer, we have 2 ethyl groups attached, whereas here 1 methyl and 1 propyl, but overall formula is same, and isopropyl and methyl overall formula is same. So these are metamers of each other. In position isomerism, difference occurs on the position of the amino group. Here it is attached in one position, here in 2. So this is propane 1-amine, this is propane 2-amine, this is butane 1-amine, this is butane 2-amine. In functional isomerism, the primary, secondary and tertiary amines have the same molecular formula. Difference rises on the type of functional group. Here it is primary amine, here secondary, and here tertiary amine. Structure of amines. Amines are derivatives of nitrogen, so they have pyramidal shape. Nitrogen atom undergoes sp3 hybridization with 4 sp3 hybrid orbitals. 1 contains lone pair of electrons and 3 are containing shared pair of electrons. When this hydrogen of ammonia is replaced by alkyl group, we get primary amine. When 2 alkyl groups replace hydrogens, it is secondary amine, and when 3 alkyl groups replace, it's a tertiary amine. In ammonia, the bond angle is 107 degrees. This, because of alkyl groups, increases because of repulsion to 108 in tertiary amines. Optical activity of amines. Because in amines, the nitrogen atom is sp3 hybridized. So there are 4 sp3 hybrid orbitals, of which one contains lone pair of electron. So they can have 2 different isomers. Especially when nitrogen atom has 3 different groups attached to it, they can have a mirror image which is non-superimposable. So they can be regarded as optical isomers of each other. But these isomers cannot be resolved or separated from each other because they instantly and rapidly flip into one another. So they cannot be isolated. So unlike chiral carbon compounds, chiral amines cannot be resolved. This is because the 2 enantiomeric forms rapidly interconvert into one another by a process called nitrogen inversion or amine inversion. This is also called flipping. It is like opening of an umbrella inside out. This inversion, which resembles an umbrella turning inside out, is very easy and occurs rapidly. The rate 2.3 into 10 is for 10 per second. As a result of interconversion, it's very difficult to isolate a pure sample of either enantiomer. The flipping occurs by conversion of sp3 hybridized nitrogen atom into planar sp2 hybridized nitrogen atom, which can then convert itself into either of the 2 forms, either this form or this form. So this process is called flipping. These 2 are enantiomers, but they cannot be resolved because they rapidly convert into one another. But although simple amines cannot be resolved into enantiomers, these special chiral compounds can be resolved. This is a compound containing a chiral carbon atom with amine group attached to it. So because the chirality is because of carbon atom, these do not rapidly flip into one another and can be resolved. This is butane 2-amine. And also, if there is if the lone pair is also engaged in bonding, in case of quaternary ammonium salts, then also flipping is not possible and these 2 enantiomers of each other can be resolved. So here the nitrogen atom is chiral, the 4 groups attached to it are different from each other. Similarly, nitrogen oxides of tertiary amines also have 3 different groups and oxygen, so they can be resolved into each other. So lone pair of electrons on nitrogen atom is involved in nitrogen inversion because in these particular cases the lone pair has been replaced with a shared pair, so they can be resolved into their different isomers. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.